Seeing Spaceship Earth brought a great paradigm shift in science. It changed our scientific understanding of the planet. And it led to our scientists becoming our planetary navigators, warning the rest of us that we are flying into danger.
Keiner aussteigen kann. Und ich denke, dieses Bild, der blaue Planet oder Raumschiff Erde, das ist durch die bemannte Raumfahrt tatsächlich geprägt worden und hat Wirkung erzielt und bewirkt weiter. Das hat die Wissenschaftler durchaus motiviert, sich mit dieser Thematik intensiver zu beschäftigen, alle mit dem Ziel, die Erde zu beobachten. Und der Hintergrund ist natürlich, besser zu verstehen, was auf unserer Erde passiert, warum schmelzen die Gletscher ab, wie stark ist unsere irdische Atmosphäre von Gasen belastet, die der Mensch freisetzt. Ein riesiges Programm. Wir haben also eine ganze Serie von Satelliten in der Pipeline, alle mit dem Ziel, die Erde zu beobachten.
Satellite monitoring of carbon dioxide over a year produces a picture of the Earth breathing. In the northern hemisphere, green plants inhale CO2 in spring and exhale it in autumn, while the opposite is true in the south. Every year, the residual CO2 levels creep up. There's more CO2 in our atmosphere than there has been for 800,000 years, making Earth hotter than when humanity was born. The unprecedented situation requires our scientists to take on the role of navigating Spaceship Earth. Everywhere in the world, they are assessing the impacts of global warming and trying to foretell what future lies ahead for our ship. Their attention is focused on the Arctic, where warming is most extreme and the ecosystem is collapsing. Young researchers are working across the remote region. They are analyzing thawing permafrost, changing animal behavior, the decreasing reflectivity of snow cover, melting glaciers, and unusual plumes of ancient gases. It is an extraordinary opportunity for a new generation of scientists to take on the most important challenge the world has known.
Ceux-ci sont des mares de fond. C'est des petits étangs qui sont formés par le dégel du pergélisol. Et le fond est tapissé avec des micro-organismes qui produisent du méthane, un gaz à effet de serre important. C'est ce gaz que nous voulons échantillonner. C'est la première fois que je fais de la recherche en Arctique. Ah oui, j'adore, c'est vraiment beau. Je rencontre d'autres chercheurs qui font des affaires très intéressantes. C'est toute une expérience.
They are the first in their fields to witness planetary changes in real time. Now, their task is to combine their findings with older data to produce a forecast for the future.
I started doing Arctic research in 1970 when I came to Cambridge as a graduate student at the Scott Polar Research Institute. I started working on waves in ice. But I'd already been on a voyage that took me to the Arctic and the Antarctic as a research assistant, so we saw both ends of the Earth, and that inspired me to take up polar research as what I was going to do with my life. When the Navy decided to send the first British nuclear submarine to the Arctic, the director of the Scott Polar Research Institute persuaded them that it would be a very good thing to do scientific work and collect ice thickness data, so he pushed me forward as the person to do it. So I've been going on them for about 40 years now. We'd be going out in the winter months. The ice then was very formidable. Most of it was called multi-year ice. That's ice that survived more than 1 year. And it was very thick, maybe 3 meters thick, heavily ridged with these great piles of deformed ice. Nobody had managed to get to the North Pole in an icebreaker in those days because the ice was so heavy. In the last 15 years, the amount of multi-year ice has diminished, and now there's scarcely any left. Nearly all the ice that's in the Arctic in winter just grew that year. So it's very thin, it's only 1 meter or so thick, it doesn't have many ridges, it's easy to break through, so you can routinely go to the North Pole in an icebreaker now, crashing through this stuff. To somebody who's used to the Arctic as it was in the 70s and 80s, it's just a different world. Well, I think the summer ice is going to disappear very fast, and my prediction is it'll happen in about 3 years' time. There'll still be ice filling the Arctic Ocean all through the winter, but it'll all disappear during the summer months. The Arctic has warmed up about 3 times as fast as the planet as a whole. There's an amplification factor. So what happens in the Arctic is what's going to happen to the rest of the planet in a few years' time.
Scientists working on the ice caps of Greenland and Antarctica are also seeing unprecedented melting. As ice melts from the glaciers, the ocean is rising.
The second picture gives you sea level rise, which is the result of melting of bodies of ice across the globe, as well as thermal expansion of the oceans. And here, during the last century, we had an average increase in sea level of about 17 centimeters.
Since 1988, the United Nations Agency, the Intergovernmental Panel on Climate Change, has been amassing data from the world's scientists to understand what global warming will do to our ship. For more than 10 years, Rajendra Pachori coordinated their efforts.
Now we have enough observations on the basis of which we have come up with very clear findings in the reports of the IPCC. And incidentally, these reports are written by the best scientists from all over the world. The IPCC doesn't pay any of the scientists anything for the work that they do. And then hit again. But the sheer importance of being part of IPCC reports is enough to see that they put in those extra hours. This is the only planet we can live on. So we have to be concerned about it. The Earth's climate system is a very finely balanced system. Nature has a certain order in everything that it does. With warmer temperatures, you'll have a higher level of evaporation of water. So therefore, that's going to affect precipitation, that means rainfall and snow. As a result of warming, the bodies of ice will melt much faster. The oceans will expand because of the heat that they are absorbing. and therefore you will get sea level rise, both as a result of the melting of ice as well as the thermal expansion of the oceans.
It is certain that the global ocean will rise through this century and the next, though no one knows how much. Predictions range from 40 centimeters to 6 meters. Even the lowest prediction means that in this century, 100 million coastal people will be flooded annually.
Complex nonlinear systems can behave in an abrupt way, and even worse, they can behave in an irreversible way. You have activated or transgressed a tipping point. If you stand in front of an abyss and somebody gives you a push from behind, you may fall down. If this person, after you are falling already, would just take the hand back, doesn't help you in any way. You will not miraculously re-emerge and be put back onto the cliff. That's what we call a tipping point. The so-called Gulf Stream system in the ocean, where we have seen a slowdown over the last decades, quite a significant slowdown already. So there have been, of course, speculations, could the Gulf Stream be shut down completely? Yes, it happened during the ice ages several times. With Greenland melting, there is a very high chance that not only this circulation will slow down in the North Atlantic, but it may be shut down completely. So that's another tipping element here, clearly. The situation for 3 or 4 years now in the United States, Canada, but you have extremely warm weather on the west coast and extremely cold weather on the east coast. This has to do very likely with the warming of the Arctic, the retreat of the sea ice, which is affecting what we call the jet stream. This is this ribbon of high-speed wind around the northern hemisphere. And in general, this jet stream is creating certain waves for a few days only, so-called Rossby waves. Now, what we find is with this disproportional Arctic warming, these Rossby waves get stuck. They can create unusual heat waves or the Californian drought. This is a big surprise for many people because they feel global warming means, oh, it's gradually getting warmer. But that our dynamical weather patterns are being reorganized through the perturbation of the jet stream, for example, in a highly nonlinear way by human interference, it's a completely different story. It's fascinating, but it's also terrifying.
We are living in a world which already has a lot of stresses. If you look at some parts of the world, there already is a major problem with availability of water. And with climate change, in some places, that's going to become far more serious because climate change only adds to some of these stresses.